Hi, everybody. Hi, everybody. So when we first added today as an option to the agenda, we were like, we'll get like a third of our attendees on an extra day. And you blew that out of the water. So thank you for coming. I'm sorry that we do not have more space. Like I said, we did not expect this kind of turnout for today. I will do a better job of making sure that's included on the registration next time. Everything that we are doing today is going to be streamed on the platform. So if you decide this room is too hot and stuffy, if you decide there's better one, if you want to introvert and get some alone time, you can attend the meeting from anywhere else in the hotel.
If you want to get internet somewhere.
There's not enough internet. So my apologies. I'm sorry. I cannot fix it, but I can prostrate myself in front of all of you. And then the other kicker is the Wi-Fi. It's just the hotel Wi-Fi, all in one hotel, and it's kind of not great in this corner. We do have the meetings Wi-Fi, which I am reserving for presenters while they are presenting to make sure we get it out to everybody. So when you're presenting, I'm going to send you a message with that secret code, and please get off when you're done. I think those are the two that I have, and I think the rest is Jules' problem.
Oh, ask online if they can hear us. Oh, can people online please indicate whether or not they can hear us? Give a thumbs up, somebody. David, give a thumbs up. Drew, give a thumbs up. All my people are remote today. I don't know what that means.
We got a thumbs up.
Okay, that's good. All right, so a couple things here. 1/3 of the people participating in this meeting are remote, and the only interaction they have is via Huba. And that means I encourage everybody to fill in their bio so that you can see, they can see you and you can see what they've been doing. Also, use the online forums and the chat and ask questions online. Don't forget our friends who are, my people are all over there in the building doing this remotely. Let's see. Bathrooms are out the door, turn right, and just go counterclockwise. Oh, excellent, bathrooms, great. Code of conduct. The DEI working group, Diversity, Equity, and Inclusion working group, has put together a code of conduct. This is the first time that an RV Tech meeting has had one. There's a link to it in the UNO's website and on the Huba platform. And the easy thing is to just be nice.
Introduce yourself. And you can share when you're ready.
This is not Ryan.
No. Unfortunately, Ryan Kaiser had some trouble with travel. Like trouble with tribbles over there. So he will not be able to make it today. Unfortunately, since he was supposed to present the first half of this. So excuse me if I fumble a bit. Oh, I'm sorry. I thought you had a question already. I am Mike Simpson, his colleague and member of the virtual cybersecurity services team from OmniSOC assigned to the fleet. We're providing operational security services to all operators. So if you haven't talked to us yet, and you're saying, where are my cybersecurity services? Come talk to us. We can help you with that. And I'll talk more tomorrow about what is on offer, what we can help you with, and how to get hold of us. So if you want to know that, come back tomorrow. In the meantime, we're going to on some more technical kind of issues. Assuming technology works. All right, great. Doing the happy dance. So as I said before, your virtual cybersecurity team from OmniSOC. You may have also heard the term research SOC. That's previously a NSF-funded project to provide cybersecurity services to NSF major facilities. That is now moved into a sustainability model as a bundle of services that OmniSOC provides, and which you've contracted with us to do. And we are very, very pleased. You're all outstanding people, great to work with, and you have an absolutely fantastic mission. We're very happy to be able to be a part of it. I am here with two of my colleagues, Mike and Chris, which you'll see more on their bios from the icebreakers. As I only have an hour, we'll go ahead and get into it. So one of the services that we have available for the both the ship and shore facilities are network honeypots. And in fact, we have a little demo running in this room. If you want to connect to that wireless access point, be kind. It's a little travel router about this big. I too was not expecting this many people. So it does not have internet connection. It only is able to talk to the small network that has two honeypots with those two IPs on the left. If you connect and you have an IP address between the two at the bottom, you're on the right network. If you have something different, you may not be on the right network. Please don't just randomly scan things. However, if you're on the demo network, primarily scan the honeypots. The only other things on there are running the demo. So be kind to your neighbors and don't like knock over the server. It will stop showing data and such. And I'll be able to show screenshots of that tomorrow during the meeting as to what happened today. Or if you'd like to see what happened more live, come see me, and I'm happy to pull it up on my screen there and we can look at it. So what we wanted to talk about today, well, I say we, Ryan and I were supposed to be here together. It's just me now. First, we're going to talk about the fundamentals, some jargon, and the OSI model for networking. So Ethernet networking. Then we're going to touch on a few useful tools that hopefully you're able to play with on our little demo network. But these can also be great troubleshooting tools to figure out problems on your ship or on shoreside facilities. Find those pesky devices that everybody says you should inventory, but no, very few people tell you how. I'll tell you how if we want to have a longer conversation about it. But you can also use these tools for this. So first, some jargon. Just like any specialized field, especially technology related, there's a bunch of terms and protocols and alphabet soup, etc. But any given network communication is almost certainly going to involve the use of several different protocols that exist for different purposes. A single packet is a encapsulated data message that's sent across the network. Technically speaking, packet is not the correct term in all cases. However, it's become the common term for any encapsulated bit of data on a network. And that's the one that we're going to go ahead and use today. So if you're thinking to yourself as I'm describing something and say, no, that's actually just bits on the wire, or that's actually a frame, or a datagram, or any of those other terms, it's okay. I probably realize it, but we're just going to use packets for today. Packets are the building blocks of network communications for Ethernet. There's other things for other types of network, but we're going to talk about Ethernet today. And they are the primary means of successfully sending data across a network, whether that's a wired network or a wireless network. When the packet reaches the destination, it needs to know which application it's going to be talking to. And that's usually when that port number comes in. You'll have one port number assigned to one application most often. Each host on the network will be identified by its IP address. It also has other identifiers, but we're going to talk mainly about IP addresses. This is a hopefully unique number per device. You can get collisions, but again, ideal world, we're going to say every device has its own unique IP address. And there are two major formats for IP currently in use, and that's IPv4 and IPv6. Although IPv6 is the new kid on the block, it's over a decade old actually. It's not as readily deployed still. Most places still are using IPv4, which is fine. There are advantages to IPv6, but because IPv4 is the primary deployed method, we're going to talk mainly about that. We also have another bit of jargon, domain names. These are the human readable, like google.com is a domain name. There's a service called DNS that will translate that for the computer to an IP address. And then it uses the IP address for all the networking. So this is the OSI model of networking. It's a little bit complicated, but for the most part, what we're really going to be talking about is layer 3 primarily. So that's the networking. That's where all those IP addresses primarily live. The data link layer, the main thing for that you should remember are MAC addresses. So capital M-A-C. Machine access control. That's the six pairs of hexadecimal, if I'm getting that right, that identifies a particular interface on the computer. The rest are really great to know, but if you're just troubleshooting some basic conductivity on a network, it's a bit overkill. Okay, sorry. So Internet Protocol, or IP. This gets the packets from the source to the destination, primarily. You saw the model. All of that is actually involved in most communications. So it's not just IP. Oh, okay. But again, we're going to simplify things and mostly talk about Internet Protocol. As I said, there's two primary forms of it employed today. IPv4 uses a 32-bit long address, and it's divided up into 4 what are called octets. Primarily, those are represented by a 3-digit number, 0 to 255. Or for those that can count in binary, that's 8 bits. So an octet. And those are separated by periods. There's approximately 4.3 billion possible addresses there. However, not all of those are available. And it's about a third actually aren't available for transmission between sites on the internet. Though some are reserved, often referred to as private IP addresses, for your own